Assalamualaikum and hi, we are from Group 7 today. We want to talk about our group project.
For the introduction, stormwater drainage is one of the inventions that very important right now for the development of the country. There are various designs of drainage with different shapes that been designed specifically for different land area. The function is to ensure that natural disaster did not happen in the area because of stormwater like flash flood and soil erosion. The purpose stormwater drainage is to flow the excessive rainwater to other natural like stream, pond or the lake. The objective of this project, firstly, is to state the name of the stormwater drainage design manual required to be used authority for drainage design in Malaysia. The second objective is to identify and justify the reason why flash flood occurs at the study area that has been chosen. And the lastly is to propose one flood mitigation method for the study area, including the analysis that supports the proposal that is being presented. For the problem statement, the first one is the drainage system right now is poorly managed and not effective to reduce the risk of flood happen. The second problem statement is the stormwater drainage size and type is not suitable anymore for the area because of the rapid development.
Hello, I'm Cik Muhammad Ridwan. I will continue for the case study. The red area represents the area where the project will be run around at Taman University Parit Raja. The flow of direction of the drainage is from BHP Petrol Pump to Restaurant Suhaila and from Restaurant Suhaila to RG Grand Hotel. This project only requires us to analyze stormwater drainage in order to identify why the large floods have hit this area. It needs to be analyzed because a suitable stormwater drainage should be designed in the planet area and designed using the rational method. Each design needs to be calculated by using the method to make sure it fits around the planet area. The Urban Stormwater Management Manual for Malaysia was used to identify peak discharge queue for the stormwater drainage at the area. For methodology part, we will find a few variables to identify the new design of stormwater drainage is fit to the area to avoid the flood. First of all, we need to find the dimension and area. The dimension and area of the stormwater drainage should be found first. The dimensions such as top height, water perimeter, hydraulic radius, and hydraulic depth, and also area needs to calculate by using upper channel geometric method. Second, the Manning roughness and the Manning roughness value can be taken from the table available in MASMA second edition. Value of Manning roughness for stormwater drainage from HP petrol pump to restaurant Sahila is 0.035 because the area is covered by short grass which is below 150 millimeter and 0.018 for stormwater drainage from restaurant Sahila to RG Grand because the stormwater drainage in this area is concrete and rock finish. For the friction slope, we use the formula which is S equal to highest value elevation minus lowest value elevation per length of channel. For the empirical IDF curve, since the research area is located in the district of Batu Pahat, our group has used data in the table from sector GPS Batu Pahat. Value to find the IDF empirical curve will be taken from the table in the MASMA second edition. For calculate the Q peak, we use the formula to find the Q, which is Q equal to C times I times A per 316. And lastly, we need to compare the Q peak of all design and the new design. All design Q must be lower than the new design Q. The new design avoids flooding by passing through the building if its Q value is lower. If not, the new design must be alternate to increase the Q value.
For this part, result and data analysis. For open channel sections, stormwater drainage from BH Petrol to Restaurant Sohaila. For the calculation for all design is Z is 1.667. So for the area trapezoidal for the all is 30.003 meter per square, and P is 16.66 meter, and R is 1.8 meter. For the new design trapezoidal, we have area get 48 meter per square, and P is 20 point 42 meter, and R is 2.35 meter. For the friction, S is 0.001 meter. And then the TD, for the TD, all TD, we get 13.227 minute, and the all TD, the D all the D for all is 0.22045 hour. So after that, for TD new, we get 11.07 minute, and for D new, we get 0.1845 hour. And then for the state, we at the Johor station ID is 1829002, station name sector GPS Batu Pahat. And then this is our size. The B is 5 and the Y is 3. The T is 5.5. So for I all, we get 291.616 millimeter per hour, and after that for I new, we get 313.934 millimeter per hour. For type of development, we use commercial and business. So the runoff coefficient, we use more than 10 years, and so C is 0.95. For Q all, we get it 6.156 meter cube per second. For Q new, we get 6.627 meter cube per second. So we get the conclusion is, since Q new is larger than Q old, so the proposed new design is pass.
Assalamualaikum and hi, my name is Muhammad Nuriman bin Faizul with metric number AF220055. Now, I will talk about the result and data analysis of our group, the open channel section stormwater design from Sohaila to RG Grant to RG Grant. Okay, at the left hand side, this is our old design for stormwater drainage, and the other side is new design. So our target is to find the final result, which is flow rate for both design by applying the rational method from MSMA second edition, and the minimum ARI for both design that we assume is 100 year, while the surface of the drainage is n equal to 0.018, and by applying the equation from table 3.1 from the report, we will get the result for area, weighted perimeter, and hydraulic radius. And this is our result. And by applying the equation 3.3 from the report, we will get a frictional slope which is S equal to 0.003 meter. After that, we need to find the time d in minute, and we need to convert it to hour. And this is the time for both design. So because the location of our project is located to sector, and the location of our project is located to sector JPS Batu Pahat according to MSMA second edition. From there, we will find the data for lambda, k, theta, and n to calculate the Embry IDF curve for both design. And the runoff coefficient is 0.95 because the type of the development of this area is commercial and business. By then, we will calculate the flow rate, and the flow rate for all design is 3.26 meter cube per second, while for the new design is 3.33 meter cube per second. And from there, after we get the flow rate, since flow rate for new design is more than flow rate old design, so the proposed new design is passed. And because the flow rate of new design is fast, the flood, we can prevent the flood that happen to the area.
Discussion. As a result of the calculation above, the suggested new design of the channel section has a major improvement because the flow of design and the discharge of flow shown to be higher than the old design. Furthermore, we observe that each drainage size rate of flow is different in the channel's length and depth. With the help of Google's Earth, to study and calculate the area given, the types of grass drain with short grass cover less than 150 mm were determined with the value of n as 0.035 based on the value of Manning's roughness coefficient n. The drainage friction slope S must then be calculated with the end result being 0.003 and 0.001 for both of the drainage systems, and additionally we decided to increase the drainage depth and length to safeguard against flash flood during the rainy season and prevent flooding. The flow will also flow the water. For the conclusion, drainage design plays a big part before applying to any type of residential area. The type of material when making the mixture can be crucial because the drainage properties need to be followed by condition and area of the place. For example, the properties or the ratio of the mixture can be a cause of failure in the drainage system. The properties of the material will have a huge impact if done correctly and will cause a failure if done wrongly. Most drainage problems can be avoided in the position and configuration of the road, as drainage design is used most appropriately in alignment and gradient planning. Hydrological variables to consider when determining the path are the number of stream crossing, side slope, and moisture regime.